We're on to the final section of mechanics, and we're going to look at work and power. Work is done when energy is transferred, which simply means that work is a measure of how much energy you've transferred. And there's an equation which says that work is equal to the force multiplied by the distance. But we need to be careful. The force and the distance, we have to watch the directions of these. You notice that in the diagram below, the woman is pulling the box with a force F, but the box isn't moving in the same direction as the force. It's moving horizontally instead. That means that only the horizontal component of F is doing any work. So if you want to calculate the work done, then you need to take the horizontal component of F, which in this diagram would be F multiplied by cos y, and then you multiply that to find the work done by the distance that the box moves. On to power. And power is a measure of the work done per second. It's measured in watts, and we see the equations for this on the left hand side. So power is equal to work divided by time, and since work is equal to force multiplied by the displacement or the distance, then power must be equal to the force multiplied by the displacement or the distance over time. But what is displacement over time? Well, displacement or distance over time is velocity. So power must also be equal to force multiplied by velocity. We now move on to the conservation of energy, and this is used everywhere in physics questions. And essentially this states that in a closed system, energy cannot be created or destroyed. It can only be changed from one form into another. Let's look at an example of this. We have a block which is held above the ground, and that has a potential energy. The block is allowed to fall to the ground, and at the point where it reaches the ground, all of the potential energy has been converted into kinetic energy. So if you know what the potential energy is of the block, which you can calculate from mass multiplied by g multiplied by the h, which is the height above the earth, and you let it fall, then you know that at the point it reaches the earth, all of that gravitational potential energy will have been converted into kinetic energy, and the equation for kinetic energy is a half mass multiplied by the square of the velocity. So sometimes you'll get questions which ask you to work out the velocity of the object as it hits the earth, and if you know what height the object was originally held at and you know the mass of the object, then this is quite easy to work out. And that concludes all of mechanics.
Created using Powtoon.